If the Earth's 4.6 billion year history were a book, what we can read today are likely only fragments and scraps. Most of the pages have long since been torn to shreds by weathering, erosion, and violent geological movements. But have you ever wondered if there might be a place on this planet that has preserved almost entirely the oldest, most crucial, and most breathtaking chapters of this book? This place lies not atop any mountain peak, nor in the heart of any continent, but sealed within the icy, silent rocks of the ocean's 10,000-meter depths. These are no ordinary stones. They are Earth's black boxes, faithfully recording a global fever that has raged for millions of years. Witness the cataclysm that led to the complete extinction of the dinosaurs. They even hold the ultimate clues to the origin of life. There they lie, in boundless darkness and under terrifying pressure, quietly waiting for us to decipher them. Today, we follow in the footsteps of generations of scientists, boarding humanity's most advanced deep-sea drilling vessel to unlock these time capsules sealed by the ocean depths for millions of years. Uncover the nearly forgotten true history of our planet.
The ground beneath our feet appears solid and eternal. But if you stretch time to the geological scale, you'll discover this place is actually an extremely turbulent and unstable realm. Over millions of years, towering mountains were leveled to the ground, while oceans rose into plateaus under tectonic pressure. Wind, frost, rain, and snow like tireless erasers have continuously wiped away the Earth's historical traces. Therefore, the rock records we find on land are often fragmented and disorganized, filled with numerous blank pages. Geologists refer to this as geologic gaps. So the question arises, given how fragmented the history on land is, where should we go to find the continuous and altered Earth archive? The answer lies in that vast expanse covering over 70% of the Earth's surface, the oceans. Unlike the turbulent land, the deep ocean floor is a relatively tranquil world. Here, there is no wind to blow, no rain to fall, and it remains untouched by the vast majority of severe physical erosion. For billions of years, cosmic dust, continental sand, the remains of marine life, and volcanic ash have drifted down like snowflakes quietly, evenly, and continuously layered upon layer, covering the ocean floor. Here, the passage of time becomes the thickness of sediment. The deeper it is buried, the more ancient the area it records. These sediments eventually become compacted and solidified, transforming into what we call sedimentary rock. They function like a super chronicle, with each millimeter of thickness potentially representing decades or even centuries of time. In theory, if we could drill through the stone history book, we could turn its pages one by one to read Earth's past. This wildly romantic idea gave birth in the mid-20th century to one of the most ambitious and enduring international scientific collaborations in human history, the Scientific Ocean Drilling Program, from the 1968 Gromada Challenger to the later resolution than Japan's Earth. And now our nation's future leading dream. Generation after generation of scientists and engineers have poured their wisdom and courage into the seemingly impossible mission to drill deeper into the deep-sea crust. These drilling vessels are less ships than floating scientific cities. They can operate in the middle of the ocean, braving towering waves to precisely drill kilometer-long drill pipes through thousands of meters of seawater into the seabed. Below, then retrieve precious rock cores one by one. Each rock core is a continuous time capsule. As it was carefully dissected, a grand detective drama spanning time and space officially commenced. And the scientists were the lead detectives in this grand production. When the first batch of deep-sea cores arrived at the laboratory, scientists were presented with a series of seemingly unremarkable cylinders. Through the various magnifying glasses of modern science, these silent stones began to tell earth-shattering stories. Crew 1 Earth's magnetic recording tape. You may not know that our Earth is actually a giant magnet with the South Pole and the North Pole. But this magnetic field is far from static. Over the course of geological time, it undergoes sudden reversals. The South Pole becomes the North Pole, and vice versa. This phenomenon has occurred hundreds, perhaps thousands of times. Yet due to the fragmentary nature of terrestrial records, scientists have long been unable to determine exactly how these reversals occur. The emergence of deep-sea cores has completely changed all that. When molten magma surges up from the mid-ocean ridge, the birthplace of oceanic plates, and cools into new rock, the tiny magnetic minerals within it act like countless miniature compasses, instantly locking onto the direction of the Earth's magnetic field at that moment. As the plates continue to expand outward, these rocks, which record the direction of the Earth's magnetic field during different periods, are continuously transported like a gigantic conveyor belt to the depths of the ocean. When scientists analyzed rock cores extracted from the mid-ocean ridge, They were astonished to discover that the magnetic field orientations of these rocks formed perfectly symmetrical alternating bands of positive and negative polarity, aligned precisely along the ridge's axis. This is like a tape recording of the Earth's pulse, providing irrefutable proof for the theories of seafloor spreading and plate tectonics. It represents a revolutionary understanding of how our planet functions. By deciphering this magnetic tape, scientists not only gained a ruler for precisely dating geological eras, but also, for the first time, witnessed the magnificent journey of continental drift with their own eyes. Clue to the cosmic fingerprint that ended the dinosaurs. 66 million years ago, the Earth's dominant species, the dinosaurs, along with over 3/4 of all species on the planet at the time, vanished mysteriously. This is the famous Cretaceous Paleogene mass extinction. For a long time, people argued fiercely over its cause: supervolcanoes, climate upheaval. All sorts of hypotheses, but none had definitive proof. The real breakthrough, you guessed it, came from the deep sea. In 1980, Nobel laureate Luis Alvarez and his son Walter's team made a startling discovery while examining rock formations on land and in shallow seas. Within the thin layer of clay that marked the end of the dinosaur era, they detected an extremely unusual element: iridium. Iridium is extremely rare, scarcely present in the Earth's crust, yet abundant in asteroids and meteorites. The iridium content in this clay layer is hundreds, even thousands of times higher than the normal levels in the surrounding strata. A bold hypothesis emerges. Could it be that an iridium-rich asteroid collided with Earth 66 million years ago? This hypothesis was highly controversial at the time. Many people believed this might be merely a localized phenomenon. To prove it is a global event, we must find this cosmic fingerprint of the iridium anomaly in synchronous strata across the globe. The ultimate and most compelling evidence comes from the deep-sea drilling program, which retrieved core samples from multiple deep-sea basins including the Pacific Ocean and the Caribbean Sea. In those places far from any continent, considered the most isolated on Earth, scientists have once again found that unmistakable iridium anomaly signal in the same geological strata. Whether in the Atlantic or the Pacific, no matter how deep the waters run, this fingerprint from space stands out clearly. It stands as a declaration to the world, proving that 66 million years ago, a cataclysmic impact truly occurred. Subsequent research also uncovered the massive Chicxulub crater over 100 kilometers in diameter on Mexico's Yucatan Peninsula. This colossal impact site stands as the point of impact for this cosmic catastrophe. The thin layer of clay found in deep-sea cores formed when vaporized rock and dust from an asteroid impact dispersed globally and eventually settled. It is not only an epitaph for the age of dinosaurs, but also the deepest ocean's most sober and complete on-site record of the apocalypse preserved for us. Clue 3: the medical record of the global fever. Remember what we mentioned at the beginning, that Earth once had a high fever that lasted millions of years. The Paleocene Eocene thermal maximum pedum, which occurred approximately 66 million years ago, has its medical records similarly preserved within deep-sea rock cores. This time, the scientists probed were the calcium shells of foraminifer microscopic marine microorganisms dormant within the rock core, too small to be seen with the naked eye. During their lifetime, foraminifer use calcium and carbonate ions from seawater to build tiny shells for themselves. After they die, these shells sink to the ocean floor and become part of the sediment. Hidden within these shells lies the key to deciphering ancient seawater temperatures: oxygen isotopes. Simply put, there are two types of oxygen: the lighter oxygen 石榴 and the heavier oxygen 幺八. When global temperatures cool, large quantities of water containing light oxygen 石榴 become trapped in polar ice caps, increasing the proportion of heavy oxygen 石斑 seawater. Conversely, as the climate warms and ice caps melt, light oxygen 石榴 returns to the oceans, causing the proportion of oxygen 石斑 seawater to decrease. When foraminifera construct their shells, they faithfully record the ratio of oxygen 石榴 to oxygen 石八 present in the seawater at that time. Therefore, by analyzing the oxygen isotopes of foraminifera from different geological periods within rock cores, scientists obtain a continuous electrocardiogram of Earth's temperature changes. This graph clearly shows that 66 million years ago, Earth's temperature surged by 5 to 8 degrees Celsius over just a few thousand years. This represented an exceptionally rapid episode of global warming. Simultaneously, carbon isotopes indicate that massive amounts of carbon were abruptly released into the atmosphere and oceans, triggering intense greenhouse effects and ocean acidification. This ancient fever triggered a massive reshuffling of global ecosystems, particularly in the deep ocean. Every detail of this upheaval was meticulously recorded in deep-sea cores. Like a detailed medical record, these cores documented not only the symptoms of global warming and the cause massive carbon emissions, but also the consequences of ocean acidification and mass extinction. For us today, who also face the challenge of global warming, this medical record from the past serves as an invaluable yet profoundly sobering warning.
Who for the dark realm of life hidden beneath the earth. For Aegis, our conception of life has always revolved around sunlight. Photosynthesis is regarded as the energy foundation underpinning the vast majority of Earth's ecosystems. However, one of the most groundbreaking discoveries from deep-sea drilling has transported our understanding into a world of utter darkness, the deep biosphere beneath the ocean floor. As the drill penetrated dead sediments and reached the deeper oceanic crust, scientists had expected to find the realm of utter stillness. After all, hundreds or even thousands of meters below the seabed, sunlight never reaches, the pressure is immense, and nutrients are scarce. But incredibly, scientists discovered living microorganisms in these rock cores retrieved from deep underground. They are not fossils, but active, metabolizing life forms. They constitute a vast and hidden underground world. Estimates suggest that the total biomass of this dark biosphere may account for a significant portion of Earth's total biomass. These life forms do not depend on sunlight. Instead, they rely on chemosynthesis, deriving chemical energy from surrounding rocks and fluids to survive. For instance, at locations known as hydrothermal vents, the hot currents surging from Earth's depths, rich in various chemicals, serve as the sun for these dark-dwelling organisms. Deep-sea cores reveal that the scope of this dark biosphere is far more extensive and profound than we ever imagined. Life can thrive in such extreme environments that completely defy our common sense. This discovery not only completely rewrites the textbooks of life sciences, but also provides entirely new avenues for our exploration of extraterrestrial life. If life can exist within the dark, rocky depths thousands of meters below Earth's ocean floor, might similar dark life also exist beneath Mars's frigid surface or in the depths of Europa's frozen ocean?
Truth revealed in Transcendence Revelations from the Deep Sea. As we piece together these clues from the deep sea, an unprecedented panorama of Earth's history unfolds before us. This is no longer a simplified chronicle filled with conjecture and gaps, but a grand narrative rich in detail, underpinned by data and evidence. We have finally come to understand that Earth is not a static stage, but a dynamic, tightly interconnected living organism. The splitting and merging of continents influence climate, extraterrestrial impacts can rewrite the evolutionary trajectory of life, and even a slight imbalance in the Earth's internal carbon cycle is sufficient to trigger a global ecological catastrophe. All of this had been recorded with the precision of the most sophisticated instrument by the sediments of the deep sea. Yet these records from tens of millions of years ago now carry a deeply unsettling relevance to our present reality. The paleo-eutrophication event 15 million years ago served as a dress rehearsal, demonstrating what happens to Earth when massive amounts of greenhouse gases enter the atmosphere in a short period. Global temperatures are soaring, oceans are rapidly acidifying, and ecosystems are collapsing. Doesn't this sound a bit like our situation today? Research suggests that the current rate of carbon emissions driven by human activities may have already far exceeded the natural rate that triggered the Paleocene thermal maximum peak. Deep-sea cores, these ancient medical records are in fact crying out to us with facts from the distant past. The extinction of the dinosaurs teaches us just how fragile life can be. Even the rulers that dominated the Earth for over 100 million years could not survive the sudden upheaval. Yet it also reveals the resilience of life. After the catastrophe, our small mammalian ancestors seized the opportunity and eventually evolved into us humankind. Perhaps with every breath we take, every thought we think, we owe gratitude to that asteroid that ended the age of the dinosaurs, and to our humble yet resilient ancient ancestors who survived the catastrophe. Deep-sea cores reveal not only Earth's past, but also the key to understanding the present and predicting the future. It makes us realize that everything we experience today is not unique in the long river of geological history. Earth has endured periods hotter than the present and suffered extinctions more devastating than those we see today. Yet each cataclysmic upheaval has completely reshaped this planet. Conclusion: Earth's black box. Deep-sea rocks are like the black boxes aboard Earth, the spacecraft that has journeyed through the cosmos for 4.6 billion years. It recorded every violent jolt, every system failure, and every catastrophic impact. Generation after generation of scientists, like the most persistent decoders, are striving to decipher information about our past, present, and future from these silent stones. Where do we come from? What have we experienced? Where are we headed? The answers to these ultimate questions may lie very deep within the crust of the ocean floor, 10,000 meters below the surface. With the launch of more advanced oceanographic drilling vessels like China's Dream, we will undoubtedly drill deeper, retrieve older rock cores, and uncover the more elusive secrets of Earth's history. How did life first emerge? When did plate tectonics begin? And in the more distant past, what unimaginable upheavals did Earth endure? Reading this history book from the deep sea may be about more than just satisfying curiosity. In this Anthropocene era where human activity has become a key geological force, this may be the only way to avoid repeating past mistakes and ensure our continued survival on this blue planet. Regarding the secrets of Earth, regarding our own history, we have only just begun to read the first page.
If you're also fascinated by our planet's past and future, captivated by the ultimate mysteries hidden in the deep ocean and the Earth's core, we invite you to subscribe to our channel. Let's continue this journey of exploring the unknown together.